Hello students, welcome to Academic Heights. Learn from home. Why Academic Heights? You will get clarity in understanding. Crystal clear concepts, you will get it. I give core and basics in each topic. Discuss in each topic. We discuss in each topic. You will indirectly prepare for your future competency. So overall, your turning point starts here. So let us see very short answer type questions. In lecture 1, I have covered 1 to 5. I will give the description above. So go through it first lesson. First lecture, go through it. After that, continuation of this one. So we'll solve some questions from 6 to possible extent. So what is the question he has given? The decimal expansion of a rational number 327 by 2 cube into 5 will terminate after. So this is in the form of p by q. So if you simplify p by q form, definitely sometimes you may get terminating or sometimes you may get non-terminating. But if the denominator has in the form of this one only 2's and 5's, if the combination of only 2's and 5, definitely it terminates. So how to get after how many decimals it terminates? So basically it depends on 3 steps. First step 1. The step 1 is whether the given number p by q is a number he has given. Whether this number is in the standard form or not, you have to check it. Whether it is a standard form or not. So the given number is in the standard form. We cannot further simplify this one. We cannot further simplify it. So that it is in the standard form. So what is step 1? You have to check whether the given rational number p by q, whether it is in the standard form or not. So it is in the standard form. Step 2. You have to write the denominators. Already denominator definitely it is in the form of 2 to the power of m into 5 to the power of n. Why, sir? Why? Because of it is already given clearly, it is terminating decimal. When terminating decimal, definitely the denominator is in the form of 2 power m and 5 power. Here 2 power 3 into 5 power 1. It is clearly given. So then what is the third step and how we'll decide that after how many decimals it terminates? Simple. We will compare these two numbers, the 2 power m and 5 power n. We compare m and n. Which is more? That is the number will use that after those many decimals it terminates. So we have to check whether m is greater than n or whether m is less than n or whether m is equal to n. We have to check these conditions. So in this question, 2 to the power of 3 into 5 to the power of 1. What is the maximum power? 3. We have to select maximum of m and n will gives the answer, maximum of m comma n. So what is the maximum here? 3. 3 is greater than 1. So after 3 decimals it terminates. So this is the answer for us. Simple steps. Step 1, we have to check whether the given rational number is in the standard form or not. Second step, definitely it is terminating decimal, so that this can be written as, the denominator can be written as 2 to the power of m into 5 to the power of n, where m, n are non-negative integers. If not, we can call it as a whole numbers. Then how to decide that after how many decimals it terminates? We have to take the maximum power of 2 or 5. So in this, what is the maximum power? 3 is the maximum power. 5 is the power of 1. We have 5 power 1, 2 power 3. So 3 is the answer. After 3 decimal places, it is terminates. So come to the next question. Which of the following rational numbers have terminating decimal? Same thing. Same thing. So we have to identify which are terminating decimals. We have to identify. So we have to go for step 1, step 2. Simple steps. Step 1 and step 2. So what is step 1? Earlier we have discussed that whether the given rational number is in the standard form or not. Check it. Whether the given rational number is it in the standard form or not. Check it. So check it. 16 by 225, it is in the standard form. 5 by 18 is also in the standard form. 2 by 21 is also in the standard. 7 by 250 is also in the standard form. So what is the standard form? We cannot further simplify. We cannot simplify it further. So that is nothing but a standard form. So all numbers are in the standard form. Then the denominator, definitely the denominator, if you write is in the form of 2 to the power of m into 5 to the power of n. If you write the denominator in the form of 2 power m into 5 power n, then those rational numbers, we can say that those are terminating decimals. Those rational numbers, definitely it is terminating. If you look at the definition, so the down of that I have given the note. Let x is equal to p by q be a rational number such that the prime factoration of q of the form 2 to the power of n 5 power m, where m and are non-negative integers, then x has a decimal expansion which terminates. Simple. If you write the denominator in the form of 2 power m into 5 power n, only 2 and 5, not other than that, it is a terminating decimal. So look at how can we write this 225. So 225 I'm going to write as a prime factoration. I will find the prime factoration of this one. It is, the number is end with 5, definitely it is divisible by 5. So 5 4s are 20, 2 is left out, 25, 5 5 are. Again the number is end with 5, it is divisible. 5 9s are 45. So 9 will goes by 3 table, 3 3s are 9. So 225. So 225 can be written as 5 into 5 and 3 into 3. That is 5 square into 3 square. 5 square into 3 square. Now, similarly, I will write 18. Find the prime factoration of 8. Product of prime factors. So it goes by 2 table. Because of it is an even number. 2 9s are 18. And 9 goes by 3 table. 3 3s are 1. 3 3s are 9. And 3 1s are 3. So 18 can be written as 2 to the power of 1 and 3 to the power of 2. 3 2s are there, only 2 1s. 2 is there. Similarly, 21. Prime factoration of 21. So it goes by 3 table, 3 7s, 21. So this can be written as 3 to the power of 1 into 7 to the power. Next comes this one. Next comes this one. 250. So 250 can write it as goes by 5 table. 5 5s are 25, 5 zeros are, and 5 10s are, next 5 2s are, so 2 1s are. So this can be written as 2 to the power of 1 into 5 to the power of 3. So here clearly we can discard these two numbers. One is second one we can discard it. This is not in the form of 2 power m into 5 power n. It should be have 2 and 5 only, but we got other than 2 and 5, we got 3 here, and we can discard this one also. So we should have only 2s and 5s, but we have 3s and 7s. We can discard this one. So after discarding this, what is left to us? The fourth one we can clearly, we can state that it is a terminating decimal, no doubt about it, that is in the form of 2 power m into 5 power n. But in the first question he has wrongly given that is the number 225. It is 1220. So we will do this problem again. So no problem, we'll do this again. So 1225. So we'll factorize it. Again. So what we'll get it here? Okay. So that is the number actually 1225. So definitely this number is end with 5. Definitely it goes by 5 tables. 5 2s are 10, 2 left out 22, 5 4s are 20, again 2 left out 5 5s. Again definitely it goes by 5 table only. Why? Because of this number is having unit digit 5. So 5 4s are 20, 4 left out, 4 left out, 5 9s are 45. 5 9s are 45. Next it is, so what is mistake here? 5 2s are 10, 5 4s are 5 5 4s are 20, 5 4s are 20, 12 20, 12 25. So once again I will do. So this is the number 1225. 1225. This is the number 1225. So 1225 will factorize it. Perfectly can factorize it. So 5 2s are 10. So 2 left out 22. 5 4s are 20. 2 left out 5 0. So 245. Again it goes by 5 table. 5 4s are 20. 20. 5 left out 45. 5 9s are 45. So 7 7s are 45. 7 7s are 49. So this can be written as 5 square into 7 power 2. 5 square into 7 power 2. It's 125. 225. 2 to 5. It goes by 5 4s are 20. 5 5s. It's 125. So in the first option, he has wrongly given this is 225. This is 620. This is 620. 625. So factorize 625. We will express it as in the product of prime factors. So factorize it, it goes by 5 table. 5 ones are 5, so 1 is left out, 12. 5 twos are 10, 2 left out, 5 5s. So I can go with 5 table again. So 5 twos are 10, 2 left out, 25, 5 5s. So 5 5s are 25 and 5 ones are 5. So this 625, I wrote it as, I'm writing it as 5 power 4. So 5 power 4 into 2 to the power of 0, I can write it. 2 to the power of 0. So the denominator can be expressed as in terms of pure 2's 2 power m's or pure 5 power n's or 2 power m into 5 power. So that is a terminating decimal. You know that it is a terminating decimal. So this is in the form of 5 power n. So it is a terminating decimal. Here 1 and 4 is the right options. We can go for 1 and 4. So D is the right option here. D is the right option. So please go through it. It is a printing mistake. It is. That's why we have taken a lot of time to solve this one. Next question. It's based on simple Euclid division lemma statement. So what is Euclid division lemma states? For two positive integers a and b, there exists unique integer q and r such that a is equal to bq plus r, where r must satisfy. So what is Euclid division lemma? If a is divided with b, a is divided with b, so a can be expressed as bq plus r. So the remainder, when you divide a with b, the remainder is always less than the divisor. The remainder is always less than the divisor, but sometimes it is equal to 0. So R having the condition, the remainder are less than or equal to, but strictly less than B. So here, which option we have? C option. We have option C. Next question. P to the power of n is equal to a into 5 whole power n. For p power n to end with digit 0, p power n to end with digit 0, a is equal to how much for natural number n? So what is a? Any natural number, even number, odd number, none of this. Simple. If any number is end with a 0, this is very, very important. If any number end with a 0, so that is having two prime factors. What are the two prime factors? It should have two prime factors, 2 as well as 5. It should have two prime factors, 2 and 5. Then only that is end with 0. So 2 5s are 10. 2 5s are 10. So the product is 10. That's why definitely that is end with 0. That is end with 0. So it's a very simple question. We can understand that it should be have prime factors 2 and 5. So 5 is already we have prime factor. So what about 2? So a directly it is equal to r. So in the options we don't have any 2 option, so that we can go for, shall we go for any natural number? No, we cannot go for any natural number. We cannot go for odd number. Odd into odd, again odd you will get it, you never get 0. Even prime number, yeah, this is maybe shorts here. Every even number, it consists 2 as a factor. Every even number, it consists 2 as a factor, so that we can decide that B is the correct option. B is the correct option. It's a very simple common sense question. If any number is end with 0, means that number should have prime factors 2 and 5 definitely. 5 is already given in the question. 5 is already given in the question. So A must have 2 factor. So where we'll get 2? Not in any natural number, not in odd number, even number. So even number is the right answer. So this is another way of thinking. Same question. HCF is always multiples of LCM, factor of LCM, divisible by LCM, A and C both. So it is a factor of LCM. It is a factor of LCM. HCF is always a factor of LCM. So when it is a factor, when we call it as a factor, it is less than that. So HCF is less than LCM. Less than LCM. So we'll check this one. With one of the counter example, we can take it. So I can take 10 comma 4. 10 comma 4. I will find HCF of 10 comma 4. I will find LCM of 10 comma. So what will get, we'll see. So 10 can be written as 2 5s. Prime factorization of 10 is 2 5s. 4 can be written as 2 to the power of 2. 2 square I can write it. So as you know that, what is HCF? What is HCF? Common prime numbers of smallest power. We have to take the smallest power of common prime number. So here we have 2 and 2 in the both the numbers. So what is the smallest power of 2? So either 2 power 1 or 2 power 2. Which is the smallest power? 2 power 1 or 2 power 1. So it should be have common number also. So common factor which is having smallest power, that is HCF. Smallest power of common prime factor is HCF. So that is 2 power 1. LCM of 10 comma 4. Greatest power of prime factors involved in that number. So 2 power 1, 2 power 2. What is the greatest power of prime factor? 2 power 2. So whichever prime number it is involved, we have to take that power. So 5 is involved, 5 power 1 we can take it, 5 power 1. 5 is also involved in this. Here we will not see any common factor. We'll see whichever prime number it is involved, we have to take the highest power of that. 2 is already involved in this, 2 numbers, but we have to take the highest power of that. 5 is not involved, but even though we have to take the power. So here what is the result? We got it as 2, and this is 4 5s are 20. 4 5s are 20. Here 2 and 20. What is the relation between 2 and 20? So clearly HCF is a factor of LCM. 2 is a factor. 2 is a factor of 20. 2 is a factor of 20. So we can conclude that B is the right option here. We'll go to the next question. All decimal numbers are rationals, irrational numbers, real numbers, and integers. First of all, decimal numbers. Decimals we can divide into 3 ways. All the decimal numbers we can divide into 3 ways. So what are those decimals? What are the types of decimals we have? So one is terminating decimals. Terminating decimals, for example, 0. Non-terminating decimals, non-terminating but repeating decimals, non-terminating but repeating decimals. For example, 0.2. Wow. This is non-terminating but repeating. 2 is repeating. 2, 0.2222. So other type of decimals we have neither terminating, non-recurring decimals. Neither terminating, non-recurring decimals. For example, 0.10, 100, 100, 100, 100, so on. So all these concepts you have already learned in the 9th class. So what are these? Terminating and non-terminating. Terminating and non-terminating. It comes under rational number. It comes under rational number. Neither terminating, non-recurring. This is comes under irrational number. So all decimals, whatever we have decimals, we can categorize it of 3. All these are decimal numbers. So this is the combination of Q and Q dash. What is Q and Q dash? What is the combination of rational numbers and irrational numbers? So that is nothing but we have real numbers. Real numbers is the combination of rationals and irrationals. So in real numbers, we have all types of decimals, which is terminating, non-terminating, neither terminating, non-recurring decimals. So here your option is real numbers. C is the right option. I hope you understood. Next, which of these numbers always end with the digit 6? 3 numbers are there, very peculiar numbers. One is 1 power n. So 1 power n is always end with 1. 1 power n, it is always end with 1. So 1 power 1, 1 power 2, 1 power 3, whatever the power of n, the n must be anything, so it is end with 1. So 1 is a peculiar term, peculiar number. Similarly 5 power n. If I take different values for n, 5 to the power of 1, 5 to the power of 2, 5 to the power of 3. So in the answer you will get the unit digit as 5. How it is? 5 power 1 is 5 values 5. 5 power 2 25. 5 power 3 125. So what is the unit digit? Unit digit is always 5. So n may be anything. Is it a odd number or even number? So 5 power n is always end with 5. Similarly 6 to the power of n. So if you give the different values for n, I'm taking 1, I'm taking 2, taking 3. The result, if you look at the result, 6 power 1 is 6, 6 power 2 is 36, 6 power 3 is 216. The unit digit always end with 6. Always end with 6. So that these are the 3 peculiar numbers. It is always with the same digit, end with the same digit. So one more it is there, 10, but it is a 2-digit number. 10 to the power of n, 10 to the power of n is always end with 0. The unit digit is always end with 0. This is another number, but it is comes under 2-digit number. So these are the 3 different numbers. It is all end with the same number, 1, 5, 6. So 6 power n is always end with 6. It is always end with 6. So your option is goes to C. C is the right option here. I hope all of you understood. What is the general form of even number? So first of all, what is the definition of even number? It is completely divisible by 2. If not, it is a multiple of 2. When it is a multiple of 2, we can write that 2 into some integer. 2 into some integer. So even numbers, even integers in the form of 2m. So we can write it as 2m. Clearly it is 2m. So according to the definition, it is clearly divisible by 2. When it is clearly divisible by 2, it is nothing but multiples of 2. So how to write multiple of 2 to m? A very simple question. Think about it. If you have any questions, comment. Now, write the form in which every odd integer can be written taking t as a variable. So all even numbers we can write in the form of 2m. So what about odd numbers? First of all, you think about what is odd integer. So when a number divided with 2, a number divide with 2, so a is divided with 2. When a number divided with 2, you will get remainder 1. Then only we can call it as a odd number. Odd number means you will get remainder 1. So a is the number I have taken when I'm dividing with 2. If a is a odd number, then a can be written as 2 into quotient some quotient plus remainder is 1. A is equal to 2q plus 1. A is equal to 2q plus 1. A is equal to 2m plus 1. A is equal to, I can write 2t plus 1. So I can change the variable. So it is in the form of 2t plus 1. He told that clearly take t as a variable. So 2t plus 1. As simple as that. Even numbers is in the form of 2m. Odd numbers is in the form of 2m plus 1. But he told that take t as a variable. So 2t plus 1. As simple as we can write it is in the. Next question. What would be the value of n for which n square minus 1 is divisible by 8? N square minus 1 divisible by 8. This is very important statement. N square minus 1 is one number. It is divisible by 8 is another number. So n square minus 1 divided by 8 means it is completely dividing. So when we divide with 8, we are getting remainder as 0. It is possible when the numerator is even number. The numerator is even number and denominator is also even number. Then only it is possible. If it is an odd number, it is not possible. So n square minus 1 is divisible by 8. That means n square minus 1 should be even number. N square minus 1 should be even number. Therefore, what I am concluding, n square minus 1 is an even number. Next, take minus 1 to that side. N square is equal to even number plus 1. So definitely if you add 1 to the even number, you will get odd number. N square is equal to odd number. When n square is equal to odd number, definitely n is equal to odd number. N is equal to odd number. So very important. So here, what is your option? Even number or odd number? So what value of n? He has given that what value of n? So n should be odd number. N should be odd number. Then only it is possible. It is possible. Simple. N square minus 1 is divisible by 8 means definitely it is even number. When n square minus 1 is an even number, n square is equal to odd number, then n should be odd number. Why? Because of odd number square is always odd. Odd number square is always odd. When you are getting odd number means, so it should be odd number square. So n is equal to odd number. I hope it is understood. What can you say about the product of non-zero rational number and irrational number? So if I take a comma b both are rationals. If I take a and b, both are rationals. A and b are two numbers, both are rationals. If I apply any Operation A circle B. Here circle means maybe it is a plus, maybe it is a minus, maybe multiplication, maybe division. If A circle B, definitely it is a rational number. If you take two rational numbers, their operation, whatever the operation, if you take it, always it is a rational number. Come to this one. One is we are taking a rational number and one we are taking a irrational number. So one is the rational number, one is irrational number. The addition of these two, A plus B, is a irrational number. A minus B is also irrational number. A minus B is also irrational number. And A into B is also irrational number. A divided by B also irrational number. So if I take two rationals, the operation, any operation, if I take, so that is a rational number. But here it is, one is rational number and one is irrational number. If you take any operation, you will get irrational number. Simple. Rational into irrational is irrational. Rational into irrational is irrational. It is irrational. I hope I have given several examples. You can go through it. 17th question. After how many decimal places this decimal expansion will terminate? Is already given, it is terminating decimal. So after how many digits it terminates? So just we'll go for step 1, step 2, step 3. What is step 1? Just recall step 1. The given number should be a standard form. Whatever the given number, P by Q form, should be standard form. Yes, this number is in the form of standard form. Then he has clearly given it is a terminating decimal. When it is a terminating decimal, so definitely denominator we can write it is in the form of 2 power m into 5 power n. Only 2's and 5's will be there. The combination of 2's and 5's, not any other number. So that denominator we can express it as 2 power m into 5 power n. Let's see the denominator. What is the denominator here? Cube is equal to 1250. This is the denominator. So we are finding the prime factorization of that. So 1250. So this is the number we'll divide with 2. 5 2's are 10, 5 5's are 25, and 0 0. Again it goes by 2, 5. 5 5's are 25 and 0, we can put it same. 5 10's are 50. Again with 5, 5 2's are 10. So this 1250, is nothing but Q. I can express it as 5 power 4 into 2 to the power of 1, 2 to the power 5 power 4 into 2 to the power of 1. So the denominator we express it as 2 to the power of m into 5 to the power of n. Then what is the last step? How to decide that after how many decimals it terminates? The based on which is greater power, 5 power is greater or 2 power is greater. So the greater power will give the answer, the greater power of either 5 or 2. We have to consider the greater power of 5 or 2's. So here we have 4 and 1 are the powers, which is a greater power 4. 4 is greater than 1. So after 4 decimal places it terminate, definitely terminate. So what is your answer? After 4 decimals. After 4 decimals it terminates. Next question. Before that we'll sum up this. Simple. The denominator we express it as 2 to the power of m into 5 to the power of n based on the highest power of 2 or 5. We have to consider it as those many digits. After that it is terminates. highest power of 2 and 5. Maximum of maximum power of 2 and 5, maximum of 4 comma 1. What is the maximum? 4 comma 1. After 4 decimals it is terminates. Next question, find the least number which is divisible by all numbers from 1 to 10, both are inclusive. Least number, find the least number which is divisible by all the numbers. The number which is divisible by 1, number 2, 3, 4, 5. So find that number. He is asking indirectly LCM. LCM of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have to find one number that number is divisible by all these numbers. Find the LCM. Find the LCM. I will go with 5 table. So it is goes by, this goes here, 5 ones are 5 and 5 twos, remaining number as it is, remaining numbers as it is. So this concept you already studied, no need to emphasize on this more. So I'm giving clearly this one. Next I will take 3. So 3 ones are 3 and 3 twos are 6, 3 threes are 9. So these are the numbers, it is gone, and remaining numbers as it is. 1 2 is as it is, 4 1 is also as it is, and 7 and 8 is also as. Next I'm using 2. It goes by 2, it goes by 1, it goes by 4, it goes by 1, and it goes by 2. 2 twos are 4, like that, and the remaining all same numbers. 1 is same, 1 is same, is same, 7 is same, 3 is same. So if you look at the last digits, whatever we got, the last one, I think we can go for one more step. So I can go with 2 table. So 2 ones are 2, 2 twos are 4. So 1 1 1 1 7 3 1. So if you look at in the last step, so all these are prime numbers. 2 is a prime number, 3 is a prime number, 7 is a prime number. So we got all the prime numbers. No need of go for further. So we can write it as the product of all these ones. So product of all these numbers, we can write it. So how many 2's we have? 2 cube into 2 cube, 1 2 3, 2 cube into 3 square, now 3 square, 2 cube into 3 square into 5 into 7, 5 into. So this is the number will give that it is divisible by all these numbers. So 8 into 9 into 5 into 7. I can multiply in this way. This is 40 and this is 9 7 63. So 63 into 4. So if I multiply it, 2520. So 2520 is only one number. It is divisible by each and every number 1 to 10. So this is the number. It is divisible by each and every number. So that is your LCM. So in this question, he is asking only LCM. The last step we did not continue. Why? Because of this is all are prime numbers. So what are these? All are prime numbers. Next one. The number 525 and 3000 are divisible by 3, 5, 15, 25, and 75. What is HCF of 525 and 3000? What is HCF? What is HCF? Highest common factor. So divisible by, when it is divisible by these many numbers, when it is divisible by these many numbers, so all these are common factors for these two numbers. For these two numbers, these are the common factors. In that highest we have to consider. What is the highest common factor? HCF is 75. Highest common factor. This 75 divides 525 as well as 3000. So we have to take the highest common factor. So very simple question, that is 75. What will be the digit at the unit place of 9 power n? Earlier we have already discussed about 1 power n. It is always end with unit digit 1. 5 power n, it is always end with 5. 6 power n, it is always end with 6. So these are the different numbers. He is asking about 9. So we'll take different values for n. N is equal to 1, we'll take 2, we'll take 3, we'll take 4, we'll take so on, we'll check it. So 9 power 1, 9 power 1, that is 9. 9 power 2, that is nothing but 9 9s are 81. Here the unit digit is 9, 1 is coming clearly. So your answer is 9R1, we can write it. Further you can cross check it. 9 cube. What is 9 cube? 9 into 9 into 9, 729. 729. So here we got is a 9 as a unit digit. 9 power 4. So how can I write 9 power 4? 81 into 81 I can write it. 81 into 81. So the unit digit is 1 1 here. So it is 1. So it is clearly that 9 power n, it is always end with either 9 or 1. So these are the counter examples I have given for this question. I hope all these very short answer questions you understood neatly. If you have any questions, yes, definitely can comment and ask that also. So that's all from my side. See you.